opposite or the same directions, depending on which inequality it is. And then if it is an inequality with the number line, you follow the closed and open circles, and then you shade to the left or the right. So these are the absolute value and inequalities from chapter 1 that we have previously talked about. What we are going to do now is, again, take the idea of piecewise, take the idea of absolute values, and we're going to apply them to a graph with a solution area and a function. So we're going to take those old ideas and sort of apply them to these new ideas. So is everybody okay with the warm-up? You're okay with finding two solutions for absolute values with equal signs and then the absolute value inequality. So this is absolute value of 2h is great or, so this is an or problem. So you have to do the positive and the negative and split the inequality. Questions, comments, concerns? Yes. They're not lines, they're just points because they're equals, so they're just dots. No shading, just solutions. Okay, so then for the activity part of this, what I want to do is have you graph that line. So again, you have the line y equals 2x plus 3. So your y-intercept is a positive 3. Your slope is a positive 2. And then you're going to plot each of those points. And then you want to describe if the point is above or below or on. So like -2, -3 is below. -2, -1 is on. -1, -1 is below, etc., etc. So then part 3 says, are all the points that satisfy the inequality y greater than 2x plus 3 going to come from above, on, or below? So you have a few ways you could figure out the answer to that question. You could take a point that is below the line, such as -2, -3, and plug that in. So if you plug in a point that came from below, we get that -3 is greater than -1. Is -3 greater than -1? No. So since that is false, then below the line answers are not true. You could pick an on the line point. If you pick a point on the line, you get -1 is greater than -1. Is -1 greater than -1? No. So on the line does not make the inequality true. So maybe we try above. Whoa. And you get 5 is greater than 1. Is 5 greater than 1? Yes. So because that inequality is true, the answer to the question are all points above. Yes.
So could it be like all points that are above and on?
Not on, because I picked a point that was on, and that gave me -1 greater than -1.
Like say for instance, if it's like another example, could they be the same? Like could it be on and above?
Yeah, so when do you think on would be true?
Yeah.
And above would be true? What would have to change about that inequality to make on and above true? What would have to change, Lucas? Exactly. So for that case to happen, I would need y greater than and equal to 2x plus 3. And that's exactly kind of what we're going to be talking about. Like when and what makes different equations true. So when we're graphing linear inequalities, like in this example here, if the inequality is greater than or less than, then we are going to make a dashed line. So it's not matching its perfectly. Hold on. That's because I changed them. And remember I told you this is like the old computer? It didn't update my stuff. I got this. All right. So an inequality is expressed as y less than mx plus b, where m still represents slope. So again, the m value still represents slope. The b value represents the y-intercept. So if we have the inequality y equals x, then my slope is 1, and my y-intercept is 0. So how would the graph of y less than x be different from the graph of y equals x? So y equals x goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc., and would be a straight line. So there's the line y equals x. The graph of y less than x would be that same line, except because the solutions do not come from it, my line would be dashed. So the line becomes dashed. And when is y less than x? Well, y is less than x below that line. So how are they different? Well, they're different because the line is dashed and shaded below. If the graph became equal to, then the only difference is the shading below. Because it's just like the example we talked about. Now my line is solid, so it's the equal to. The only difference is that it's equal to x and all values less than x. If it was y greater than x, now we're talking about everything above. So the differences would be dashed and shading above. So inequalities are going to be the solutions that are above, below, and sometimes on, and sometimes not. If it is equal to, then it will be the points on the line. So this difference will be that it is on and shaded above. So linear inequalities have more solutions than lines. Linear inequalities have more solutions than lines. A solution to an inequality is anything that makes the inequality true. So it's anything that makes the inequality true. Solutions come from the shaded region. And sometimes the line. So in example B, if I asked you to graph the inequality 2x plus 4, it has a y-intercept of 4, a slope of 2, it's greater than or equal to, so the line is solid. And it says, what is a point that is a solution to the inequality? So a point that is a solution, would it be a point from the line? So you could give 0, 4. And then if the y values are greater than, well, here's y. When is y greater? Well, it's greater up. So greater than is everything above the line. So a solution could be anything from that shaded region. So there are a ton of solutions. What is a point that is not a solution to this inequality? Well, now anything on the line would not be a solution. So 0, 4.
Excuse this interruption. We're all mathletes going to the mathlete competition series. Please report to the main lobby at this time. Thank you.
Wow. Good luck. Alright, so does that make sense to everybody, like why or where these fall? Alright, the cheat sheet is at the top of the next page then.
At least you were there for the lecture. I was there for the lecture. She gave me nothing. I wasn't there for the lecture. She gave me nothing on it in screenshot. I had to go read the book and everything, and I still have 0 code up there. She literally
Anything on the line. Yeah, well, the one is an ordered pair, so like I did 0, 4. But it could have been any point on the line. Yeah. So for you guys creative athletes, same deal as always. It's just the next page after this is your homework. Alright, if the symbol is greater than or less than, the line is dashed. If the symbol is greater than or equal to or less than or equal to, the line is solid. So the equal to makes the line solid because that makes the points on the line part of the solution. So this means points on the line are not true, points on the line are true. If the symbol is greater than or equal to, then you shade above the line. If it's less than or equal to, you shade below the line. So it says if you are going to make a graph of y greater than 2x plus 3, on which side would the shaded region be? Well, that's y greater than. So following the table above, it would be above. Because it's greater than without equal to, then the line is dotted or dashed. Same difference. And then we can check that. So you go through the y-intercept of 3 up 2 over 1. And then it says name points that would be solutions. So you have to pick points in the shaded region, but not on the line. So maybe -3, 0, 0, 6, and maybe -5, 5. And you could check any of those answers by taking that point and plugging it back in. So I could take -3, 0, and say 0 greater than 2, -3 plus 3. And I get 0 is greater than -3. And that is in fact true. Therefore my point and my shading and everything is true. If I plugged it in and it was false, like let's say I got 0 is greater than +3, then that would tell me that either the point I picked is wrong or my shading is wrong. Yes. For the homework, if I ask you to, yes. Yeah. And you don't have to do it for like all 3. Like like sometimes I give you points and I ask you to tell me true or false also. So again, going back to the beginning of this unit, We graphed lines in standard form. We graphed them in slope-intercept form. If you have a line in standard form, you have two choices. You can solve for y. If you're going to follow these rules, you have to solve for y. So if you're going to follow these rules about the above or below, you have to solve for y. If you just want to graph your points, that works also. But if you solve for y, you'd subtract 2x and divide by 4. So you get a y-intercept of 2 and a slope of negative 1/2. My line is dashed, and I get y less than, so I shade below. Y-intercept of 5, slope of negative 2, my line is solid, y is greater than, so we shade above. Questions, comments, concerns? It's not a challenging lesson. It's just one of those lessons where you have to really take everything we've sort of done so far and bring it back together. So you're doing that next page for homework. So I kind of have you answer questions about it and then pick points and then tell me if the points you picked are true or false.